Good afternoon. Welcome to the BMES NSF special session on career and unsolicited awards. This is one of two award sessions that the NSF sponsors here at BMES to tell us a little bit more about the awards programs at the NSF for both early investigators and then also pre-collegiate and doctoral, not pre-collegiate, pre-doctoral and then doctoral students as well. So welcome, it's nice to have your participation. It is my pleasure to introduce to you Michelle Grimm, who will be talking to you about the programs that are available to you for extramural funding at the NSF. So Michelle Grimm is an associate professor of bioengineering at currently at Wayne State, but moving to Michigan State January 1. She's been involved in this capacity for over 25 years. But she, about 4 years ago, went to the NSF to lead the program of engineering of biological and medical systems, or biomedical systems, and disability and rehabilitation engineering. In the last year, she moved to lead the NSF program in biomechanics and mechanobiology. Both of these are in the engineering directorate. So she brings a wealth of experience with a number of different funding opportunities at the NSF. So it's my pleasure to introduce and ask Michelle Grimm to speak to you today.
Thank you very much, Lori. Who's in the audience? How many of you are graduate students or postdoctoral fellows? Okay. How many are untenured faculty? And how many are tenured faculty? A few. Okay, great. So this, what we're going to be talking about today relates to both career proposals, career awards, and unsolicited proposals. And I still think unsolicited proposals is the oddest name for any particular funding mechanism out there, but it just means that you're applying to one of our core programs outside of a specific solicitation. So those are the two things that we're going to cover. And it is a tough time to be seeking federal funding, whether you're looking for it from NIH, NSF, any of the federal agencies. But by putting in the time and effort in advance, then you can actually improve your chances of successfully receiving funding. So this is just my idea of things to keep in mind as you go through this process. So several steps along the way. The first one is actually figuring out what program you should be applying to. And that's not that easy, and I think it's probably more difficult for biomedical engineers than for many other areas. So I'm going to ask one question, which is how many people have heard during their career that NSF does not fund research related to human health and medicine? Okay, the numbers seem to be going down since the first time I gave one of these presentations, so that's good, because NSF does in fact fund biomedical engineering related research. And we do that out of a number of different directorates and a number of different programs, which I'll highlight in a minute. Most of it comes from the engineering directorate. So this is the structure of NSF. There are a number of different discipline-based directorates which support investigators across the country. And within the engineering directorate, we have 5 divisions. 3 of them are subject matter based. So CBET is Chemical, Bioengineering, Environmental, and Transport Systems. CMMI is Civil, Mechanical, and Manufacturing Innovation. ECCS is Electrical, Communication, and Cyber Systems. And then we have 2 non-discipline specific divisions, one related to engineering education and centers and one related to industrial partnerships. Every single one of those divisions supports research related to biomedical engineering. And one of the first things I learned when I joined the NSF was the number of programs that do support BME research. When I started, the program I went in as program director for was called Biomedical Engineering. I soon realized that that was a bad name for a program because this is the number of programs at the NSF that support biomedical engineering research. So that's why the program is now called Engineering of Biomedical Systems. This handout is available at the NSF booth. I highly encourage you to stop by and get a copy, because the first thing, as I said, that you need to do is figure out what the right program is to apply to. And it's going to depend on the specific objectives of each proposal that you're going to submit. So don't get wedded to a single program, because as you look at your overall research, there may be multiple programs along the way that you want to submit to. In addition, you are going to want to consider both NSF and NIH, and looking at other federal agencies that might fund that translational aspect. So the VA is a good one. If you can get a relationship with a researcher or one of the VA medical centers, that's a great opportunity to look at that translation. So just some basic differences between NSF and NIH, which are the two major funding agencies that we rely on in this field. NSF really is looking at advancing foundational knowledge, so really keying in on that. Of course, if it's an engineering project, hopefully you're thinking about translation, because that's what engineering is. It can involve feasibility studies that can include limited numbers of human volunteers. So if it's appropriate, you can have a small number of human volunteers. Small is subjective. NSF does not fund clinical studies using the old definition of clinical study. I know NIH has now changed their definition of clinical studies. But small number of patients, feasibility, but not longer term, broader number of patient studies. One of the downsides to NSF is budgets are often more limited. So typically in engineering, for a single PI, think $100,000, including indirect costs. There is some flexibility depending on the division you're applying to, so talk to the program director. NIH is more medical condition specific, disease specific, and wants to see that translational aspect to it, much larger budget possibilities. Other than our 21s, you need to have a lot more preliminary data for NIH than you do for NSF. Most important takeaway, please, please, please do not cut and paste an NIH proposal into an NSF template or vice versa. There are different structures, there are different expectations, and yes, it is very obvious to the reviewers if you do this. So there are projects that maybe would fit both NSF and NIH, but at least write a different proposal. Don't just cut and paste it and submit it to the other agency. Okay, you've found a program. Now you want to figure out what mechanism you're going to be using. And there are several different sorts of mechanisms that you can take advantage of. Standard grants are just that. They're standard submissions and awards. Some are in response to specific solicitations, some are unsolicited. We'll talk about career awards in a few minutes. We've talked about the unsolicited program. Conferences and workshops. If you have an idea for a workshop that you think is going to really highlight advances in an area, talk to a program director, see if they might be interested in funding that. There are specific types of submissions that focus on industrial partnerships. These are called GOLI proposals. There are particular rules for those GOLI proposals, but if you have a strong industrial partnership, you may want to look into those. And eager is another one, and I'll go over that specifically in a minute because I get a lot of emails and phone calls from young faculty regarding the eager mechanism. You can look for supplements for involving teachers and undergraduate students in research, which is a great opportunity. And there are a number of special programs, and this is just a small list of what is available. I encourage you to explore the NSF website, sign up for NSF alerts, get the information about all the opportunities that might be available to support your research. So briefly, CAREER. CAREER is an agency-wide program at NSF. Every directorate that provides funding participates in the CAREER program. And the goal of it is to provide longer-term, 5-year funding so that investigators can establish both a research career and a career as an educator. So there is expected to be an integrated research and educational component to the proposal. One of the key aspects is thinking about how this career award is going to advance your career, not just what are you going to do for that 5 years, but how is this going to jumpstart the rest of your academic career? There is a goal to encourage participation and increase participation of investigators from typically underrepresented groups. General guidelines, 5 years in engineering must be at least $500,000, depending on the program that you are applying to. Some, such as in CMMI, so my program now in biomechanics and mechanobiology, must be exactly $500,000. That's a division policy. So again, talk to your program director. The submission deadline is always July. Okay, so this is one of those programs that has a specific deadline that you need to adhere to. In order to be eligible to submit a career proposal, you have to hold a doctoral degree by the time you submit your proposal. You have to be employed in a tenure-track or equivalent position. It used to be that the equivalent was for institutions that don't have tenure. It has been broadened slightly so that if you are in a non-tenure track position, but your department chair commits to the fact that you will have a contract that extends through the life of the award, then you are eligible if you are still a junior faculty level individual. We didn't get a lot of explanation as to why this policy changed. I personally think it's because for individuals that were applying to the Education Directorate, many of our teaching faculty who are doing education research are not tenure track, and so they were kind of blocked out from that. So this opens it up a bit, but you are not going to get enough money off of a career award to support your entire salary, so this is not really for people who are expected to support themselves on soft money, because your department chair is going to have to commit to that long-term contract. You only get 3 chances at a career. 3 strikes and you're out, okay? So think about when you're going to be submitting your career proposals. You do not need to submit one the first year you are a faculty member, okay? Think about it. Start writing it. If it's ready and you think it's a really strong proposal when you come to June, great. But if not, hold on to it, build on it, keep working on it. But make sure that you start submitting them 3 years before you're going to go up for tenure, because once you're tenured, then you're no longer eligible. So just keep all of that in mind. The Unsolicited program, that's our standard program for all levels of researchers. It is the institution that determines whether or not somebody can serve as a PI on an unsolicited proposal. So some institutions allow postdocs to submit as PIs. Others require you to have a faculty appointment. General guidelines, typically these are 3-year awards. Funding varies based on the division, and these are changing. Apparently there have been some divisions that are relaxing the guidelines. So again, talk to your program director. And I should have changed this last slide. This is what happens when I change some slides and forget to change others. That holds submission window. Any core program in engineering, okay? This does not apply for career awards, but core programs in engineering now have gone to no deadline. That means you can submit your proposal at any time during the year. The question we get most commonly now is, well, how is that going to work? Well, we're still figuring it all out. Best recommendation is write your proposal. As soon as you feel it is a strong proposal, submit it. Don't try to guess when during the fiscal year is your most opportune time to submit that proposal. Send it in. It will be paneled. We need to, or reviewed as a group. Some program directors may use ad hocs. We still have to make 75% of the decisions within 6 months of submission. So we are not going to hold them for a year and finally try to review it and get you a decision. We will be acting on these throughout the year. Eager. Okay, so we got a lot of young faculty in here. Who has been told, hey, contact your program director and ask them about funding through Eager? Only a couple people are going to admit to this. Okay. So Eager is a specific mechanism for high-risk, high-impact research that does not need to go through panel review. It does not have to have external review. It means that the program directors have a little bit of flexibility in providing funding if we feel that there is an idea that is really high risk but likely to have a high impact. However, it is not intended to be used to get preliminary data. And it is not intended to bypass deadlines if you're applying to a program that still has deadlines. You have to contact the program officer before submitting. Different program officers have different policies. It has been my long-standing policy that I will not even consider something for eager unless it has been through a peer review. The idea has been through a peer review, and the panel has said, yeah, we think this is really cool, but it's not quite there. It's still a little too high risk. Then I may reach out and consider eager funding. Now that there's no deadline, there's no excuse for not putting an idea through the peer review process first, okay? But talk to your program director. Some may be a little more flexible and be willing to provide eager awards outside of that. The whole not fund until the end of the fiscal year, now we're kind of up in no man's land on that as well, because of course we're doing this whole no deadline budget thing. So this is going to be an interesting experiment for all of us. But the best thing is talk to the program director, get their advice on what they think you should do in terms of submission. Any faculty here at a predominantly undergraduate institution? A couple. There is a mechanism that you can apply through, which basically provides an extra tag to your proposal. And this is important because as program directors, we like to have diversity in the PIs we have. We like to have diversity in ideas or topics that we're supporting, diversity in institutions. And so it's an additional aspect that we can consider when looking at a proposal. The other key piece of this is if it's tagged with the RUI program, when panelists look at that proposal, they're going to suddenly realize why you're not including lots of PhD students in your budget and your plan for completing the research. So if you are at a predominantly undergraduate institution, make use of this, okay, and take advantage of it. And it really does provide that additional information to the panel and the program director. All right, so you figured out which program you think you're going to apply to and what mechanism you're going to apply through. Now reach out to the program director. And this may be the first of many attempts that you make to reach out to the correct program director. You want to make sure that your project actually meets the scope of the program that you're applying to. For career proposals, this still is imperative because while we do move proposals around to make sure that we find the right program, you don't want to submit a proposal, have the program director say it doesn't fit our program and we can't find another program that it does fit, and now you're out a year in terms of being able to apply and have your proposal considered. So I would suggest you start with an email. That's my preference. If you don't get a response to an email, follow up with a phone call. If you don't get a response to either of those, start harassing the program officer, okay? It is one of our primary responsibilities to communicate with you. Please leave at least a week between contacts, okay? I do only get frustrated when I get an email and 2 days later I get I'm following up to make sure you got my email. It's like, okay, I've been at a conference this entire time and no, I haven't had time to respond. So give people a week, but then follow up. That is our job, to communicate with you. You can visit a program director in person if you'd like, if you happen to be in the DC area. It's not necessary. You can set up a time for a phone call, okay? And as I said, different program directors have different ways they work. I don't take cold calls. If you've ever called my voicemail, you'll get a message that says, please send an email to set up a time to make for a phone conversation. So, but you can talk by phone, you can talk by email, you can talk in person, you can find somebody at a conference, have that conversation. If you're going to be talking by phone or communicating by email, make sure you send the program director a concise summary of what you're hoping to do. That helps them evaluate whether your area of research fits their program. I strongly encourage that summary to include the actual objectives for your project, because remember what I said at the beginning? As biomedical engineers, our research can kind of move between programs. Which program it's going to fit depends on the specific objectives for that project. So make sure you include those. Don't wait until the last minute to reach out to a program director. And yes, I have actually received emails from PIs a week before a deadline saying, hey, can you tell me if this project fits your program? Well, if I tell you no, how much time are you going to have to work on something? If I tell you you need to focus on something a little more, how much time are you going to adjust? So please reach out well in advance. Program officers at NSF can have significant influence in deciding what projects to fund or not. So it's important that they get to know your research, get to know you. Our recommendations are primarily influenced by the panels and the panel reviews, but when judging how we're going to distribute our budget, maybe we know a little bit more about your area of research and we think it's really cool and it's going to advance the field, and so maybe you get that extra little bump. One of the things that we can give you is good general guidance on proposal writing tips. We do not, however, read an entire proposal and give you feedback on that draft. Okay, that's what your mentors are for. That's not what program directors are for. So, but I'm happy to always talk with PIs about general grantsmanship issues that apply to everybody. Okay, so now you've talked to your program director, you know which program you're submitting to. Now you actually have to make sure the proposal is ready to be submitted. This is the Bible of NSF. It's called the PAPPG, or the Proposal Award Policies and Procedures Guide, hence the reason we use acronyms. Please, 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 please read through the sections that are relevant in terms of what needs to be in a proposal, because this specifically covers areas that you need to focus on as the PI in terms of writing your proposal. It talks about the required sections. It talks about the required headings of sections. And yes, the 18.1 PAPPG specifies that all proposals have to have a section with a heading, intellectual merit, and a section with a heading, broader impact, both within the body of the proposal. And proposals have been returned because they don't have those specific headings, okay? So you need to read this, follow through with it, and I would encourage you to read it before you write and then go back and read it again before you submit and make sure you don't forget something. The criteria for NSF proposals are the same for every single proposal that we review. Some solicitations may add additional criteria, but these are the two big ones. The first one is intellectual merit. How is the work going to advance the field? How is it going to contribute to knowledge? Is it creative? Is it novel? This is where you will get hit if the proposal itself is not well organized, if it's not easy to understand. Is the PI or the team of researchers capable of doing the research, and do they have access to the resources they need? All that comes into intellectual merit. Broader impacts. Does the research and related activities have some benefit societally? Now, for biomedical engineering, hopefully, seeing as the word medical is in there, everything that we're doing eventually has an impact on human health and medicine. Don't rely on that as being the only broader impact that you point to. So I would encourage you to discuss the societal impact of your research itself, but panels and the reviewers will talk about this. Panels for biomedical engineering related projects typically expect there to be some sort of additional impact beyond, hey, if we get this, then 20 years down the road we'll cure cancer, okay, which would be wonderful, but they want to see more. Often it will include activities that focus on broadening participation in STEM, improving STEM education, public scientific literacy, some sort of outreach. So think about what that can be. Talk to your mentors, talk to the program directors, but don't just rely on this will eventually impact human health. So as you're planning your proposal, and this is hard, it's not something that necessarily can be taught, but it's definitely something you can practice, you have to start with that great idea. Understand and articulate to yourself, why is the idea important? Make sure you know what's already been done in that area. Frame the project that you are proposing based on what has already been done in the area, because you will get panelists that either are aware of that, or maybe are semi-experts and aren't, and want to see how your project fits into that. So make sure that you clearly know how this is going to advance the knowledge. How will it transform the field? And identify what is unique or novel about your work compared to what others have done before. Next, you come up with the implementation plan. How are you going to do the work? What expertise or facilities do you need? Do you have those? Are you going to have to find a collaborator? Make sure you have a letter of collaboration. Do you need to take advantage of things at another institution? That is absolutely fine as long as it's clear how you're going to access these. Include a timeline for your proposal so that the reviewers can see that, yes, this is a reasonable amount of work for the time that you're proposing. And obviously you have to work out a budget that also matches with time and effort. You should include enough preliminary data to demonstrate that you can do the work. Okay, that's what the reviewers are focused on. Are you able to actually complete the project? Are you going to be able to do what you say you're going to be doing? An NSF proposal generally has two parts. The project summary is a single page. The project description is, for most proposals, is 15 pages. Take the time and write these. Write these for semi-experts unless you're applying to a program where the program director says, you know what, my panels are so tightly formed that you can expect that everyone on that panel will be an expert in your particular subdiscipline, okay? And that's going to be rare. So in general, write for semi-experts. Start out and lead people through a story. Make sure they understand what it is that you are going to do and why. And yes, then you put in a paragraph or two in each section that goes into the deep detail, takes the deep dive. So when you get that expert as a reviewer, they say, yes, this person knows exactly what they're talking about. Not so much of a problem now that I'm involved with biomechanics and mechanobiology, but when I started in engineering of biomedical systems, I would get project summaries, that one pager. I could not understand what the PI was wanting to do. And I'm like, okay, if I can't read that one pager and figure this out, this is a problem. So make sure that you are writing so that people can actually understand what you're going to do. That's the most important thing. Keys to success. Tell a really clear story. If you struggle with writing, get somebody to help you with that, to proofread, to go through, make sure that it is truly understandable. Avoid jargon, okay? And I know that sometimes space is an issue, but don't use so many acronyms that to recover the space that people really can't follow it. So try to use acronyms that people will understand. And make sure you define them. So I was in a panel recently where the acronym HA was coming up. I'm an orthopedic biomechanist. HA to me is hydroxyapatite. For people in other areas, it's hyaluronic acid. I'm like, okay, I've got to actually tune into what is the abbreviation, what is the acronym in this particular case. So make sure you define any acronym that you use. Validation. If you're developing a model, if you're developing a system, don't forget, you are an engineer. You want to validate that system, okay? A model is only as good as the validation, even if it's limited. Talk about what the limitations are within the work that you're doing. And a new statement, and this goes along with mitigation strategies, own the limitations. Don't run away from them. So if there are limitations, but you still think yours is the best way to approach a problem, call those out, own them, explain why this is still the best way to approach it, provide those alternative plans in case something goes wrong. But you can bet that if you think there's a possible limitation to your project, there's going to be a reviewer that sees the same thing. And if you haven't identified it, they're going to identify it for you and assume that you aren't familiar enough with the area that you haven't seen that. And really make sure your broader impacts are well thought out. For career proposals, you want to project that long-term vision as a new researcher. So where do you see your career 10 years from now? There was one that was funded recently by one of my programs that projected out for 20 years. So think about where you see that your career going. For career proposals especially, it is a single PI, and you need to demonstrate that you are an independent researcher. You don't want to just be building on exactly what you did as a grad student or a postdoc and say, I'm just going to continue this work. So you want to demonstrate that you can work independently, you can do the work yourself, and that you're taking some new direction in your research. If you, as an aside to that, if your research as a postdoc truly was independent and you were doing something new and novel that your mentor wasn't really involved in, state that. claim it, okay? And then people are going to say, all right, this is this person's research, not their mentors, and so it makes sense for them to continue it. You need an integrated educational and research plan, and you tell that story. So however you want to describe that integration of your educational components and your research components is up to you, but you need to weave that together. The example I've often given is if somebody's working in nanomaterials and they want to do an educational component outreach with Lego, that's fine. They just need to explain how those work together, how those integrate together. So it doesn't need to be, I'm going to teach kindergarteners about nanomaterials, but again, tell that story, make it clear to the reviewers. Okay, you're finalizing your proposal. You want to make sure it is read by as many people as possible. People who are experts in the science. Are there any holes? Semi-experts, can they follow what you're planning on doing? Strong technical writers. Many times those first two bullets don't actually match up with that third bullet, so go out and find people who are strong technical writers. Have some previous career award recipients read through to say, does your integrated research and education plan seem to fit the bill? They don't have to be from your department. They can be from other departments, but can they, again, follow what you're planning on doing? Make sure they read it early enough that you have time to integrate their recommendations. And please, 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 make sure there are no spelling errors, there are no grammar errors, there are no missing sections, there are no missing figures, there are no missing tables. It's amazing. Every year, there is a proposal that comes through that talks about 3 aims at the front of the proposal and only 2 are listed, or figure 6 does not match up. And it's because as we proofread our own work, we read what we expect to see, and we don't catch these problems. Okay, so this is another reason it's important to have people help you read this. When you're submitting your proposal, make sure you know your institution's policies and procedures. If you're new faculty, maybe this is a shock to you, but it takes more than a day to submit a proposal. Research offices often ask for a week. Give them that time, okay? Because, and I've had this happen, sometimes things are miskeyed, sometimes there's a backup. I had a large proposal to the engineering directorate submitted once that I was a co-PI on, and somebody from the admin staff miskeyed our DUNS number, which identifies the university. It got kicked back. It got kicked back 5 minutes after the deadline, okay? And guess what? Deadlines are absolute. So if you are submitting to a program with a deadline, 5 p.m. 0000, your local time is the deadline, okay? And there's no way that we're going to give you any exception, except in cases of natural disasters. And yes, we have had to extend some program deadlines recently due to hurricanes and things of that nature. But hopefully those are the rarities. Once the proposal is submitted and it is past the deadline, do not go in and change any component of it because it resets the submission date. Okay, so you can't say, oh, I messed up and I submitted the wrong current and pending support. I want to update it. You know what? Let it go through as is. Okay, it is much better to have it reviewed than get it kicked out. Now, because of the no deadline in some of our programs, then you can reach out to a program director and say, hey, I want to update this, and there may be ways that you can do that. But talk to the program director first. Common pitfalls. Don't repeat words over and over without substantiating them. And yes, we get proposals that use novel every 5th sentence. Transformative, first time ever. Don't say first time ever unless you are absolutely sure it is first time ever. Don't forget literature exists before 1980, so make sure you go back. If you don't have a compelling scientific question and a clear pathway to answer it, that's a problem. Not all research has to be hypothesis-based, but if you are proposing a hypothesis, make sure then the experimental plan actually tests that hypothesis. If it's incremental research, that's going to mean that it does not score as well. It doesn't want to be just what is needed to get out the next paper. You want to actually be advancing the field. If there aren't convincing preliminary data so that the panelists aren't sure that you're going to be able to do the work, that's a problem. And you want to make sure that there are details in your experimental plan that people can say, yes, it makes sense with the number of specimens that are going to be tested, the statistics that are going to be done. All of that has been thought out ahead of time. And don't propose either too much work for the time period and budget or too little work for the time period and budget. Hence the reason it's important to have a timeline in there so that it's clear that, yes, you are getting the sweet spot in terms of what you are proposing. If you don't integrate education and outreach activities in your career proposal, that will be a death sentence. So please make sure you do that. Most programs now are expecting some degree of assessment of educational and outreach activities. Anybody who's been involved with ABET at their institution, what I say is think ABET level assessment. Set outcomes, measure outcomes, okay? It is not, you do not need to have an educational researcher as a partner in all of your proposals, but you want to make sure that whatever you're doing on the education and outreach side is actually having an impact. And for that educational component, especially for career proposals, you should be going beyond what we do on a daily basis as faculty members. Panelists aren't very happy if you say, I'm going to mentor graduate students and I'm going to teach a class and integrate 2 lectures of this material into my class. That's what we do every day, okay? So think beyond that day-to-day activity. All right, so you've submitted your proposal, now you wait. So we try to get decisions out within 6 months. So don't start thinking too much until you hit that sort of 6-month time point, but you may get your decision and feedback before then. It's possible that a program director or program officer will reach out to you with additional questions. That should be viewed fairly positively, but it is not a guarantee that the program officer is going to be recommending your proposal for an award, but view that in a positive light. While you're waiting, you should be writing other grant proposals, right? So that's just the life of an academic nowadays. So keep writing, think about where things are going. Can some aspects of this overall project go to other agencies? Do not submit the same proposal to multiple NSF programs, okay? Because subsequent ones will be returned without review. You can submit similar projects to multiple federal agencies. Make sure you check the box on the cover sheet saying that that's what you're doing. If you are lucky enough, and there are a few of you who are, to get support from multiple agencies on the same basic project simultaneously, we will work with you to try to make sure the budgets are legal. So therefore, you're not getting funding for the same work from multiple agencies. That's like hitting the lotto, and we will work with you if that's the case. Please don't ask the program officer to give you feedback until you get the official decision. First of all, we're not the ones that make the official decisions, okay? So even if we recommend something, on occasion it gets kicked back to us. And 2, it's much better for you to take the reviews and think about them and review them than to ask us for feedback in advance. If your proposal is declined, you want to start planning and your next submission early. If you are submitting to an unsolicited engineering program, it is 1 year for the same general project between submissions. So you have to wait that year before you submit again. Read all the reviews very carefully. Understand what they're saying. Read them once, put them aside for a week after you've like pounded on the wall or gone out and screamed or whatever you want to do. Come back, reread them again. They are supposed to provide you with critical feedback, so make sure you integrate that. Talk to the program officer at that point. You cannot resubmit essentially the same proposal. NSF does not have a true resubmission policy. There is no cover sheet to say what you've changed. You do not need to explicitly address the concerns of the reviewers. I would hope that you think about the concerns of the reviewers and think which you wanted to address, but you don't call them out specifically. But you want to take that time, and at a minimum, over a year, you should have more preliminary data, and there's probably more that's been done in the field. So those areas definitely need to be updated. What you should be targeting is something that for CBET is characterized as highly competitive, for CMMI is primary consideration, and all grades of excellent or very good, okay? A good, think of it as a C, all right? A good is not likely to get funded. So that's what you should be looking for. And then, how do you prepare yourself for success? Volunteer to serve as a reviewer. Stop by the NSF booth. If you haven't already volunteered, sign up. We have an electronic system that's there, so you can sign up to serve as a reviewer. It's a great opportunity. Even postdocs can be included in panels, so feel free to sign up as a postdoc. Take advantage of workshops like this as often as you can. You will get different information. And then identify multiple mentors that can cover different areas of your research and education career. And the most important one is to persevere. It is a tough environment to be in. Have a great idea, keep plugging at it, find the right group to support that. And thank you very much. I'm now going to call the panel up and have them join me up here. So I am pleased to be joined today by a number of individuals who are both awardees, and this is where you're going to get the real information, guys, so I would not disappear. This is the inside secrets. So can you get through?
We're trying to go in order.
Okay, so with us today we have 3 award winners, so individuals who have received NSF awards for their research, as well as 2 individuals who not only have received NSF awards, but have also served as reviewers. And so I'm going to go down the line and introduce them very quickly, and then they each have a chance to chat with you briefly, tell you their perspective, and then we're going to open it up for questions. On the questions, yep, I will, yep. So on the questions, there are 2 options. You have, somewhere along here, there we go. There are microphones in the middle of the room. I would ask that if you're going to come up and ask a question at a mic, you use the mic, because this is being recorded, so we want the questions to be recorded. In addition, if there are cards, there are note cards around at the ends of the rows, or there will be, feel free to write a question down. We'll have them collected and brought up here. So I have Ronki Olabisi from Rutgers University, Paca Robles from Georgia Tech, and Xiaorong Zhang from San Francisco State are all of our awardees. And then Rafaela DeVita from Virginia Tech and Princess Imakwede from Washington University, St. Louis are our awardees / reviewers. And Ronki, if you want to come up first.
Okay, thank you. I'm going to try to say what I learned, and hopefully it's the secret sauce. So the first thing that I learned, I think I was going about it as though that this was a 5-year project that was going to lead to kind of a career invested thing. And everybody says, don't think of it as a project, think of it as launching your career, but I really didn't get what that meant until after I did it. And so I think you go into it and you're thinking, yeah, that once I get this 5-year project done, all of the papers that come out, it's gonna, and so when I first applied for it, there was a project that was on nacre, which is a seashell. And this one person had discovered all of these things, how osteogenic it was and everything. And it was their discovery. And I thought to myself, oh, I could take this to a whole new direction and this would be amazing. And it didn't get funded. And then I took all of the comments from all the reviewers and I was like, I'm just gonna do exactly what they said and everything, and it didn't get funded. And so I was like, what am I doing wrong? And I think what clicked for me was that it wasn't my baby. It was something that somebody else discovered that I believed I could take into a better place, as opposed to something that I was discovering that would lead to my future career. And that for me was a transformative realization. And then I tried to it was a project that I thought of as a little project, not as cool as exciting. It was, yes, it was my creation, but I didn't expect to get funded, and then it did. I just kind of was like, okay, here. I think that's one of the secret sauces. That's the seed. So that seed, for me, what was I guess, revolutionary for me was it's the seed that is your original invention or idea that you will now become the future leader in. And if you don't have an idea that is all you, it's probably not going to get funded. And for me, making that idea that was all me did it. The next thing was the structure, and this was actually a huge aha moment for me. And this aha moment came after because I'd gone to grant writing session after grant writing session, and none of them worked. And I was like, I've been going to all these things. I've been listening to everything you've said. I've been memorizing it, and I did everything. It didn't matter how many mentors I went to. It didn't seem to work until I went to this one, and I immediately read this after it. And I'm going to read. I know you all can read, but I'm going to read it anyway. So adjectives in English absolutely have to be in this order: opinion, size, age, shape, color, origin, material, purpose, noun. So you can have a lovely little old rectangular green French silver whittling knife, but if you mess with that order in the slightest, you'll sound like a maniac. It's an odd thing that every English speaker uses that list, but almost none of us could write it out. And as size comes before color, green great dragons can't exist. And what was the aha for me was that in the same way that English has a particular structure, grant writing does too. And if you deviate from the structure of English, even if you can't, I don't know that order, but if somebody messes it up and they say dog brown, I know that it's wrong. If a reviewer hears an order that is wrong in this grant, then they're going to identify you as not one of us. So they will recognize you as not at our level, you're still up and coming. And so it gets to the heart of why all of these well-funded people who were giving me advice, I can't tell you that order. They couldn't tell me that order, but they could tell when it was wrong. And for me, that was the most important thing. And I went to this was one of the most important and helpful grant writing conferences I went to, but it was tailored to NIH grants. And so they deconstructed the structure of all of these successful NIH grants. And what they said, they've all got this general context, this narrowing context, the research contribution. So they hired a person who does communication, and that's what he does. And he broke it down, and he took I think it was a dozen grants, and he found the commonalities in all of them and laid it side by side. And that was, I think, the most helpful thing ever. Now, I don't want to come here and tell you what the commonalities in NSF Successful Career Awards are, because I'm not a language person, and this person who did this was a language person. But I know it exists for that. And so what I did was I asked people who had Successful Career Awards, can I borrow your award? And even though it wasn't in my field, what I did, that structure, I did not copy their grant, I copied the structure. So if they had, here, this is my aim, and this is the preliminary data for this aim, and blah, blah, I copied that. If they said, and we will prove our hypotheses by these aims, I copied that. I mean, my structure looked exactly like their structure, and that was the award that I got. So reading it sounded to the reviewers like I was one of them. And that was my secret sauce. So make it your baby, and make that baby shaped like the other babies. Okay. So, thank you.
Okay, so first, my program focuses on optical imaging. We do label-free molecular imaging, and the idea behind my program is that we want to leverage all types of light-matter interactions to extract useful molecular information and then use that information to tell us something about disease. So we really work at the interface of physics, chemistry, engineering, and medicine. And So for my proposal, one of the things that I focused on was to use all this molecular information and basically just call it phenotypical information. We get markers about what's going on in cells and tissues, and then use all that information to then say something about one of the most pressing needs in medicine, which is staging cancer, getting the correct prognosis. And so I fully agree with the previous comment that you have to take something that is yours, that is your baby, and really have a huge passion behind the project. And that's perhaps one of the most challenging parts. One is to really find that niche that is what you really care about and how to project that passion into the page. And you have to make sure that the reviewers understand that you really care about this work, that this is really who you are, and that your career is going to be centered around that. And for that, from this particular project, not only you will have a future career chasing the products of this work, but then other researchers will be inspired to do the same and to follow that line of questioning. And so here's just a few more details of what I proposed to do, which was to look again at the structure of tissue, the molecular components, and then ask, well, can we predict aggressive cancers with this type of technology? Can we say whether a patient is coming in with a melanoma, whether that patient should have a lymph node biopsy taken out, or if you can just do a resection and then call it a day? Right now, there's a huge problem in terms of how people are diagnosed, and then the prognosis behind that disease. And so you really have to solve a very critical and important problem. So certainly, I think that the secret sauce is being passionate and finding a critical problem and an engineering approach to solving that particular problem. The other recommendations that I would have already been mentioned briefly. I got so much value out of calling my program director. I talked to him for about an hour discussing different ideas and just hearing how he felt about these different ideas. I talked to him about a bunch of different grant mechanisms as well, and the feedback went to, no, I don't care about that, I am not going to fund that, to yes, this is really cool and we really care about that, that sounds awesome, do that. And I said, okay, I think we're getting somewhere now. I also think that getting examples from your colleagues, those that are in the program that you're submitting to, and maybe even those that are in different programs, but borrowing their language and their structure, just knowing where you need to put a red box or when to use bold and when to underline is really, really critical. I think reviewers are just really extremely busy all the time, and if they're not able to just go through and look at key points and get the gist of what you're proposing very quickly, they're going to get bogged down. 15 pages is a really long proposal, and so it's just a lot of hard work that you're asking very busy people to do. So you want to make their lives as easy as possible. And also to make the language and the format as familiar as possible, so that they know that they need to look at, the bottom of page 1, you should have in bold what you are planning to do, so that if they read nothing but that statement, they at least understand what it is that you're trying to do, why it's important. And so borrowing that structure is hugely important. And for me, some of my colleagues who lend me their proposals, I'm very grateful for them. So reach out to your colleagues and mentors for that. In terms of the broader impact section for the Career Award, I thought that a really useful thing was to leverage the infrastructure at your institution. So many institutions will have learning programs where they have the infrastructure to, for example, set up a summer program, or to do Lego, or to help you improve your class in a certain way. Go talk to them, because they already have language for you, they have examples for you, and you can then start to structure what you want to do for your broader impact section in terms of educational aims that you like and that fit within your project. And so I think that all of that is hugely important, and leverage all the resources that you have available. Of course, all of that goes with the fact that you have to start really early, so you can talk to as many people as you need, that you have time to think about, well, is that going to work? Is that going to fit with what I'm trying to propose, et cetera, et cetera. So take your time doing that. And another thing that's very important is that well, at least I am not an expert in everything. And so make sure that if, for example, I do optics, I do imaging, and if I'm saying that I'm going to have this mouse model to do blah, 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 I need to have a collaborator that does that. And that collaborator should be a well-known person so that the reviewers, when they're reading it, they say, yes, that person can certainly help this applicant do these aims. And so that's very important. In terms of writing, I have a very different approach. I start early and then I just obsess about it completely and just don't think about anything else except that. And so I just read it out loud to myself over and over again before I send it out to anybody. So I have a very unique way of doing that. And when I say it, when I say it out loud, I can catch very often a lot of the typos or any type of awkward phrasing of things. But one of the most important things that I always think about when I'm writing a grant is this the easiest way I can convey that idea? Don't make things unnecessarily convoluted or long. If you can split up a sentence into 2 or 3, do it. Just make sure that it's as easy as possible for the reader. I was lucky enough to just get my career award funded on the first try, so I didn't have to address any comments from reviewers, but I had to do that with NIH grants, and I certainly took all their comments to heart and address exactly what they say. But in reviewing the comments, the most important thing that you need to ask yourself is, what is the reviewer really saying? Don't just, quickly answer their question, but really think about why were they confused about that point? How can you address it? Do you need to change the aims? And really think about it critically as to what you need to do in order to not have that come up again. So I think that's about all I have to say. Yeah.
All right, hello everyone. So I'm Xiaorong Zhang. Currently, I'm an assistant professor of computer engineering at San Francisco State University. So it's my honor to be invited to this panel to share my grant writing experience. So some background information about me. So I started to work as an assistant professor at San Francisco State University in 2013. That's right after I completed my PhD from the University of Rhode Island. And I'm a recent career awardee supported by the Disability and the Rehabilitation Engineering Program. And that's also my first try of submission. I think my case is a little special because San Francisco State is one of the predominantly undergraduate institution. So it doesn't have a PhD program. That means I have to convince the reviewers that I'm able to conduct the proposal research with undergraduate and master students. So my research focuses on the development of neural-machine interfaces which interpret biosignals from the human neural control system and identify the human states such as emotion, intention, and motion, and then for the intuitive control of external devices and applications. And I mainly address the NMI challenges from a computer engineering perspective. And my career project aims to develop the next generation NMIs for EMG-controlled neural rehabilitation by integrating grid sensing, machine learning, embedded systems, and the various emerging computing technologies. So this slide shows a rough timeline of my career process. So I started to work as an assistant professor in 2013. But for quite a while, I was not sure what to do for my research. My PhD research is very highly interdisciplinary, and it requires a large investment in lab space, equipment, manpower, with intensive training in different fields. But we don't even have a PhD program at San Francisco State. So it took me about 2 years and a half. I've tried many different projects and many things. And then I finally identified my independent research direction at San Francisco State. that is to address the NMA challenges from a computer engineering perspective. And also that can be tightly integrated with my teaching. And I'm teaching like 2 embedded system related classes every semester, and I have about 100 students in my classes. But I don't take that as a heavy workload distracting me from my research. I take that as an opportunity for me to train my students, undergrad students and master students, and identify top students in my class to join my research group. And then after I identify my research direction, I established important collaborations and also obtained several internal grants and awards to work with my students to collect preliminary results. So, and in the meantime, I was lucky to be a faculty advisor of an outreach program which provides research internship opportunities to community college and high school students every year. So after I established my track record for both of my research and education, it's just naturally I started to think about maybe it's the time for me to consider submitting a career proposal. So that was in early 2017. And then in March 2017, I attended a career workshop in NSF. It was not from BME, it was actually from the Science Division, Computer and Information Science and Engineering Division. But I found it was very helpful because I met with 2 program directors on site. And most importantly, I realized that I don't need to be shy to contact program directors. So I contacted 4 PDs with my summary, and then finally identified a suitable program for my career proposal. And that's around the end of May in 2017. And then the next 2 months, basically, I just focused on developing my proposal. So I spent a lot of time reading related work, literature in a related field, and then crafting the long-term vision and also specific aims of my proposal. And then I collected collaboration letters, all the collaboration letters by the end of June, and then focus on writing for the last about 20 days. Okay. And then in March 2018, my proposal was recommended and then got funded. So some tips I want to share with future applicants and also what helped me most. So first of all, the career project, again, is your career. So you need to craft a long-term high-level vision, but also concrete steps for a 5-year plan. And then secondly, that's identify the right program. Like my research is highly interdisciplinary, so I was not sure like what is the best program that's most suitable for me. So I contacted 4 program directors from 2 different programs with my 1-page project summary. So I asked about whether you think my project fit your program or not. And other questions I asked include what would be your expectation on the educational proportion. Actually, different PDs have very different views. That's my experience. And I also asked basically any questions that you're concerned about. Just, I think you can feel free to ask the program directors. And then what was extremely helpful for me is I think you need to try to get help as much as you can from your institution, friends, senior colleagues. So for my personal experience, we have an amazing associate dean for research in our college. And she's a very successful researcher herself. She has a lot of grants, but she's from chemistry. But this is good because that means she will make sure that my proposal can be understood by a non-expert. And she basically guided me on almost every step of my proposal development. And we had back and forth over 10 revisions of my proposal, and then countless email conversations, just just writing my proposal. And other resources I got from my institution, including these templates and samples. This does not only include the project description of previous winning proposals, but also other things like a budget, data management plan, facility and resources. So these documents all take a lot of time to develop. And then next one is read example winning proposals. I think that's also very helpful for me. I got one from a former professor and several just downloaded from the internet. They're not really in my field, but I found them very useful. I just learned the structure of the proposals. Specifically, there was one I found extremely helpful for me. That was a proposal not in my field, but it was also from a non-PhD institution. And then the last but not least, so start early. Like for my personal experience, my writing of project description was extremely late. But I think compared to some of other things, that's still something you can control of your writing pace. But there are some things that you cannot control, like your budget, the department chair's letter, and collaboration letters. So I think it's helpful to have partnership already in place. And I had 6 collaboration letters for my career proposal, and it takes time to contact all the collaborators and collect all the letters. And I did that by the end of June, before the submission of my proposal. So lastly, I just want to share the structure of my career proposal. It's not universal, but I hope that you find it maybe helpful. So it's 15-page project description, and I have 2 pages of introduction. In the introduction, it has 1.5 pages overview and significance of the research, the long-term goals, and the 3 research objectives and the 3 educational objectives. And then specifically, I have a half-page institutional environment and my qualification of carrying out the proposal work. Because again, my case is a little special because we don't have a PhD program. So I want to basically convince the reviewers that I have the support from my institution and I have the qualification of carrying out all the proposal work. And then the second session, which is just required if you read the proposal guideline, so is the results from prior NSF support. I had just half page because I just contributed in a MRI grant as a co-PI. And then the third section is 1.5 pages background and challenges describing existing work in the field, remaining challenges, and background of new technologies I plan to apply and develop. So the major portion is the research plan. I had 6.5 pages. I had 4 subsections. So the first section is just the overview of my research plan, overview description of the 3 research objectives, and the overview of the NMI model to be built and evaluated. Because as like suggested by Michelle, and she is actually my program director, I asked her actually when I contacted her before I submitted my proposal, who will be the reviewers on the panel? And she said, you have to make sure that your proposal understandable by non-experts. So that's what I did to add this overview of research plan and have a general description of the high-level NMI model to be built and developed. And then the other 3 sections, so I have 1 subsection for each research objective, and for each of them, I have preliminary results or prior work. So if you have previous publication, that's great. If you do not have, try to add some prior work at least. And then that's the proposal work for the career proposal, and then an evaluation plan. So I did that for each of the research objectives. And then education is a similar structure. So I have a half-page overview of my 3 educational objectives, and I again emphasize my institution's uniqueness and my qualifications for conducting these educational activities. And then the next 3 subsections basically is the preliminary results, proposal work, and the evaluation plan for each of my educational objective. And finally, I have about half-page board impact, and just a table of the timeline of the project. So this is my proposal structure for the career project. So basically, I just wanted to convey one message to the reviewers that I know what I'm doing and I will get them done no matter this project will be funded or not. So that's the end of my presentation. I hope that's helpful to you guys. Thank you.
All right, I'm going to let Rafaela and Princess provide their initial feedback and their initial thoughts as reviewers, and then we will open this all up for questions. So, Rafaela.
Not yet. So I think that Michelle provided a very good of what we do as reviewers, and what we look when we are reviewing a proposal. I've served as a reviewer for 10 years. I think I've reviewed more than 15 to 20 proposals. So
Rafaela serves on 3 different panels for 3 different programs, so she gets grabbed quite often.
yeah, right. And so as a reviewer, I try to do a good job because I spend a lot of time writing my proposals. I want to give good feedback. And so usually what happens is the program manager will contact you and will give you maybe a list of proposals to review. And you basically are asked to, select among those, the proposal that you feel comfortable reviewing. But they're not always in your area, and they are not in your area many times, right? But you should still be able to review them, right? And so you pick maybe, you pick then 10, 12, sometimes 8, depending on the program. And then you're asked to review these. 3 of them are the one that you will be talking about, okay? And so you really have to know even the commas in that proposal. But then there are the other 7, which you also have to be able to provide input. I don't care if I'm assigned as the lead of the proposal or the reviewer. I read them, 10 of them, 8 of them. I read them the same way, and I basically write the summary or the review with the same detail, the same amount of detail. Again, because I spend a lot of time, I know how hard it is to get grants. I want to make sure that I provide the right feedback. What I do recommend as a reviewer is keep in mind that reviewers are people like you, okay? So we make mistakes. Don't be hard on the program manager, on us, if we overlook or we didn't understand what you were proposing. But I would say that try to do a very good job. What I do, I basically go by the NSF guideline. Okay, if NSF is asking me to look at the transformative nature, then I'm going to go and look for it. If NSF is asking me for novelty or integration of research and education, I will go and look at the proposal and make sure that all these things are there, all of them. Is the PI qualified? I will go and look if the PI is qualified. Now, what's a nice proposal for me is one where you have all these things written down clearly, and I don't have to suffer to find out what's novel. Because if it's not my field, I will not know if what you're proposing is novel or not, right? But if you tell me, okay, here is the state of the art, and here is now how I'm going to advance with the current knowledge, then that's great. Now, that's the proposal I like. And usually what I do, you can tell from the abstract if the proposal is a good one. Because what you do in the abstract, and what you should be doing in the abstract, in my opinion, in the summary, is all the questions that the reviewer is supposed to ask, is supposed to answer, just write the answer for each of them, right? Already in the abstract. So I already know what's novel. I know what is transformative. Say why you're qualified. Say what you're going to do in terms of outreach. Say how you're going to integrate research and education. Don't wait until the end of the 15 pages. The first page, the summary page, try to basically take the questions that Michelle had in terms of intellectual merit and broader impact and answer all of them. Okay? To me, that's a wonderful way of making the reviewer happy because, wow, I basically read just one page and I can already provide I already have a good understanding of the proposal. Then the second thing the first thing I look at any proposal is really is the proposal advancing science and engineering? That's the main question. If that's not there, I'm already turned off, right? And then the second thing I look at is how about the methods? Are the methods good methods? Can they really achieve what they want to achieve with the proposed methods, right? Are there any deficiency in the methods? And then I'll go and look at the qualification. Is the PI qualified? right? And sometimes that's a little bit tricky because you are young and you're starting your career, and maybe you do have some qualification, but not necessarily to the point that you are already, the expert, or that's totally okay. I'll look at that too. Like I say, okay, well, perhaps, it doesn't have all the preliminary data, but I'm confident that with what they've provided, or at least with the description of the methods, that they do have the qualification. So for me, those are the most important, the most important items in an NSF proposal. And then when I look at actually the career one, I'm very careful with the integration of research and education. And while it's okay to leverage on existing programs at your institution, I think I encourage you to do that. But if I see a proposal that is doing a little bit more than that, right, that's where I'm excited, right? Because if I'm already using what's there, well, I mean, okay, fine. I mean, I understand that. And I will not grade the proposal, I still give a good grade. But if I see somebody that is saying, I'm developing a new program at my institution, that's when I get excited, because you're really now doing more than just capitalizing on what's existing, right? And so those are, I would say, are the main, the main things that I will look at when I'm reviewing your proposal.
Great. Thank you. Princess?
So, hi, my name is Princess Imwakwede, and, I think that the best practices have already been said. I really enjoyed what Michelle mentioned about all the pieces of what needs to go into your proposal. And I think if there were one thing I would pick out as a reviewer that I think would truly strengthen these proposals that we review is the concept of having other people read your proposal before it's submitted. And, I thought maybe if I tell everybody, just take a couple minutes before you leave today and come up with, at minimum, 3 people that you can go to who can read that proposal before you submit it. If you have some proposal that you're planning to submit in the near future, come up with a deadline for when you're going to get it to these 3 people. And it doesn't have to be the same 3 people reading all 15 pages. In fact, I had a junior faculty member come to me this summer to just read a small section of the proposal and give some feedback. And this could happen at any point in this process. But getting the feedback early is essentially sort of shopping out peer review before it gets to us. And, oftentimes, we have a panel. So you're getting an opportunity to have a communal discussion about your proposal. So oftentimes it's not just the one person who had one rating that's sort of quote unquote derailing your proposal. It is still coming out of a panel, a community of experts. So if you can sort of simulate that community on your own before it gets to us, I think that would be a great way to help you identify whether you have all the pieces of intellectual merit, whether you have all the pieces of broader impact. In particular, career awardees who've had to go through this process over and over again, in some cases of having to resubmit, or those who have just been able to get it right the first time. So I think having those experts available to you, and if you don't have those experts available to you, or you're not sure how you can find a career awardee, there's a website, NSF, that will show you where awardees, whether it's at your university or in your area, are located. And of course, use the BME community, the BMES community, to find other people who can possibly serve in those mentoring roles. So with that said, I think that there's been a lot already said about how to really incorporate and take ownership to the research, and I think that's completely spot on, making sure that the research reflects truly how you want to build your career. And I think that this concept of broader impact is also a true opportunity for us in this room. So many of us are tenure-track. Some are also aspiring to get to that point or continue in other areas of the biomedical engineering enterprise. But I think that being able to say that we're opening the door to others and broaden participation is truly impactful. I mean, imagine a world where that was not the one of the fundamental goals of NSF. That's not a world that I think we would want to be in. So I think you should take that as the opportunity that it is, whether it means partnering with programs that are already existing in your universities, because there are people who've done some great research in the social sciences on some of the unmet needs, and they really just need an engineering partner who can see some of these programs through, or bring that extra connection of maybe a biomaterial that could, again, provide some very hands-on training for whether it's students in K through 12, or even some opportunities for students to do research and do it in a slightly different way. I mean, the possibilities are endless for what you can do to broaden impact in your local communities on a national scale, on a global scale, with the work that we're doing. And I think that you should really see it as an opportunity to really broaden impact when you get to that point in your application. So with that said, that's one of my pet peeves when someone doesn't take that opportunity for what it is. And again, I think that if you have some mentors on your campus who can read your proposals before they're submitted, they can also give that feedback and possibly even connect you to opportunities on your campus or in the community in which you can make sure that you're having an impactful, broader participation section of your proposal.
Okay, and now we will open it up to questions. So people want to come to the microphones, introduce yourself, please, and ask
Hello.
away.
I'm a graduate student from UCLA. I have a question for the first speaker and the last two speakers. For the first speaker, you mentioned that you don't own the idea, but what if you own the idea of translating this technology into like medicine or something like that? Would it be also, is this considered as owning, is this considered as your idea? And for the last two speakers, what is the red flags for seeing the PIs are unqualified for the grant?
To answer, okay, sorry. To answer the first part. So, for instance, my idea with the NACER, I thought it was really cool. I was going to take it in a completely new direction, but no matter what, the pioneering work was done by this person. No matter what I did, I was not the pioneer in that. So it's not to say that for all NSF grants you have to be the pioneer, but if you're not the pioneer in a career award, then you're already going uphill, because this is their, like, it's so prestigious that if there's 20 other people who are going to be a pioneer and you're going to change something, do you see what I mean?
Yes. So pioneer means that they already have a nature paper, a science paper of whatever they're doing.
No, you don't. I don't have any of that.
Oh, okay.
No, it was something that nobody else had done. I stumbled upon this novel thing that I found. But I don't have any of that, but it is definitely mine. Nobody else is going to be the pioneer in this. I mean, mine specifically is wound healing. I'm not the only one doing wound healing. I'm the only one doing it this way.
I see.
Raphael
I
and
can
Chris-
perhaps answer this question as well, because I can relate to what you're feeling or thinking. The first time I submitted my career, it was basically on trying to understand the viscoelastic property, non-linear viscoelastic property of ligaments, okay? So I got the review back, and I got very high scores, but of course, didn't get funded. And the comments were, wow, your methods are great. You know, the modeling is great, the experiments is great, but ligament and tendons, everybody's working on ligament and tendons. I'm like, okay, but they're not doing what I want to do. Still, you know, the proposal didn't sound very exciting. And so it was around May, I was pregnant. And Virginia Tech has a very large campus. You have to cross sometimes a drill field to go to the other class. And I had, my baby was due in July, so big belly, walking around. And I just starting to feel some pain, like somebody was stretching, you know, my belly was getting too big. And I go teach, come back. The first thing I do, I go to my office and I Google pain. You know, I feel like my uterus is overstretched, something is going on. And so Google say, oh, these are your broad ligaments. Your broad ligaments are getting overstretched because the uterus is getting too big. And I was like, ligament? Broad ligament? And so I immediately tried to see, is there anybody who has done this? Because this could be something that now would be, you know, my thing. And so then that's what I did. I started to look. I didn't work on the broad ligaments because for other reasons, but the uterosacral ligament and cardinal ligaments. So next time I submit my proposal, of course, I had to change the first 2-3 pages of motivation because now I was talking about pelvic floor disorders, prolapse. You know, nothing has been done in this area. Submitted while I was pregnant, had a baby while everything was happening, and I got it. So you see, that's what she's saying. It's not that you have to now come up with something like, but you have to establish your niche. Mm-hmm. You have to establish your uniqueness in the field, right? Mm-hmm. And so I think that's what she's talking about. That's what you should think about, something that is going to make you unique. Mm-hmm. And then for the second question that you're asking about qualification, what we want to find out is, do you have any preliminary data, right? If you don't have any preliminary data, it's hard for me to say if you're qualified. Mm-hmm. Or have you done something that is related to it, right? Mm-hmm. Say, for example, in my case, that I'm going to propose to do some mechanical experiments on single cells. And I have never done single cell. All I've done is tissue cells, right? Neither I show any preliminary data. Well, can I really say that I'm qualified? It will be harder, right? And so I don't. That's what we mean, you know, when we say easy.
Would you be checking also like previous publications to see if they are qualified or not?
Well,
or?
that's what. No, I'm not going to do that because that's something you need to tell me in your proposal.
I see.
So that's what you say. I've done this and published in this, and you exactly tell me that you have done, because we don't have time to go and read everybody's paper, right? You have to cite and you have to tell me I'm qualified because, right? And so then I will understand. So that's why I'm saying when you look at those questions, really answer them and you say I'm qualified because I've done this, I've published this, and so on and so forth. Mm-hmm.
Thank you.
Applied engineering work. Okay. And I just want to add to what, and this will depend on your program director. So again, talk to the program director. But reviewers who've sat on my panels, I say, especially for a career, don't say they haven't published it yet, therefore it's not, they haven't established their pedigree in this area. If they provide the preliminary data in the proposal, that is sufficient. And I knock them over the head with this concept over and over again, because we can't expect people, especially writing early career awards, to have something published and on that timeline and everything for everything that they're going to do. Otherwise, by the time you actually get published, you're now tenured or you're hoping for tenure and you run out of your clock. Anyway, okay. Princess, do you have anything else to add to that?
Well, I think that to add on to the preliminary data point, also be able to establish that you can present the right rigor to that work. So really showcase your ability to do science well, whether it's including whatever statistical analysis, and you don't have to write a long description, just describing, I used, these approaches as you're analyzing your data. So, make sure you're very rigorous in the way you present the preliminary data, because that really shows well to the reviewers.
Okay, I have a question from the audience. Can you comment on what advancing knowledge would be seen at for an applied engineering work? How can you address this in a grant? So for a more engineering approach versus a scientific approach, how would you expect to see that in a grant proposal? Anybody? Paco?
Yeah, I can answer. So for me, what's important, as I said, is advanced engineering and science. So many times what we see, especially in the biomedical engineering programs, is basically that, let's say you're looking at the effect of a drug on a tissue or on some types of mechanism, right? And then what you're looking, or for example, in my case, what is the effect of pregnancy on the property of these ligaments? And what I'm doing, I'm using old methods that have been developed, well established, maybe for cardiovascular mechanics. Nothing is new because I'm using the old thing. And I'm just applying that to two different tissues, maybe a rat before pregnancy and a rat after delivered, right? I don't see that as transformative novel because all I'm using are old methods, at least for the engineering side of things. Yes, you will answer a new question. And maybe that would be appropriate for NIH. But for NSF, I want to see what are you going to advance in terms of engineering and science. Are you going to develop a new way of testing the tissue? Are you going to come up with a new modeling framework? So those are the things I'm looking at. And so I think that's That's what we mean by advancing science and engineering. We want the development of new engineering methods and new science.
And I would also add to that that a really easy shortcut towards that is very clearly communicating what the limitations have been in the field. So if you can communicate those limitations and then talk about how you're going to advance past the limitations, or your technology moves us in a way that has never been seen before, that's the way that, you know, we are able to understand what you mean by, you know, advancing technology. So I often feel like the best proposals that I read are proposals where I feel like I'm learning something afterwards. So I almost want to invoke you to think of us as students. Think of us as students of your intellectual merit and of your broader impacts, and teach us how you're moving things forward.
So from my point of view, in my work, I build tools, right? And so if you have the appropriate tool to solve a certain problem, then you need to sell why that tool is the specific thing that you need to solve that problem, and establish that the methods that are out there right now are not getting at the problem adequately. And so now you're going to build this thing that is able to just nail it. And that then establishes impact, because you're just acquiring more tools to solve problems, and then people build on that. And so I think if you can establish that there's this huge problem, there's no method to do it any other way, and so you're going to come up with the best way to do that, and use that as a platform to then progress engineering and science, and to then be able to ask even more questions. I think that's how you really frame the fact that through an engineering approach, you have this huge impact in the community.
Hi, Handa Najar, University of Oklahoma. My question will be about writing. In terms of clarity, you were telling that we need to be really, really clear because maybe the reviewers are not in our field. How the reviewers are being selected? Yes, we can be a reviewer, but is it something like, let's say, NSF CAREER reviewers are always them? And how are they being changed? So I'm just trying to understand how the reviewers are, how do you select them? How it's changing?
It will vary between programs, and different program directors have different ways of approaching it. So I will describe what I do, and we have numerous other program directors that are here, so it's a great question to ask once you've figured out your program, to figure out how they select their reviewers. I'm actually enjoying right now a year where my program is narrower, but for 2 years I had very diverse programs, and I could guarantee, especially for career panels, that not all the reviewers on an engineering and biomedical systems panel were going to be experts in a particular area, and definitely not disability and rehabilitation engineering. When you go in disability and rehabilitation engineering, a single panel could go from brain-computer interfaces to understanding the properties of ligaments that are important in prolapse post-pregnancy. You're not going to have, people aren't going to be experts in every one of those areas. So the way I approach it, I have a database of reviewers. People can email me, add themselves to the database of the reviewers. When I see what proposals come in, the first call goes out to, hey, are you available for these dates? And then once I get a group of reviewers that are available, I narrow it down based on expertise and try to get in at least an individual who has a general understanding. So I would have a tissue biomechanist, somebody with expertise in exoskeleton, somebody with expertise in brain-computer interfaces, a physical therapist. Basically, I try to build a diverse panel so that there is somebody who has a reasonable understanding of every proposal. And if I can't find that, I'll go out and get an ad hoc to add to that. But you build it based on availability, you build it based on expertise, but you can bet that there is not going to be, you're not going to get 3 or 4 reviewers, depending on whether it's an unsolicited or a career proposal, who are experts in your particular sub-area. Because if we've got 30 proposals in a panel, I just can't find that many people that are going to be expert in all those diverse areas. Some program directors may have more go-to people And I admit, as I said, poor Rafaela, first of all, she's fairly close, being Virginia Tech, but because of her broad expertise, she gets called upon frequently, and she's very generous with her time.
NSF is generous with me too.
But we do try to get diverse voices in and not have the same people all the time. And unlike NIH, the panel that reviews a proposal the second time around will be different. Maybe there are some people that overlap, but it will be a different group of people than reviewed it the first time. Yes.
I'm Jaideep Desai from Wichita State University. My question is to Dr. Zhang. There were 6 collaboration letters in your NSF career proposal, right? Can you highlight or provide more information about how deep or how well described your collaboration efforts into your proposal, because NSF guideline template is, one-line statement. I believe one of the letter comes from your department chair, the supporting letter, but the other 5 letters, how well you described in your proposal, which shows really good collaboration efforts, actually.
Sure. Actually, yeah, I have one department letter from department chair, but I still have another 6 additional collaboration letters. And they have to follow the same template, just that one sentence. But basically, so for these 6 collaboration letters, one of them was from my research collaboration that's specifically on one of my research objectives. So when I describe the preliminary work, and proposal work, and evaluation plan, I specifically said that for this work, on this part, I'm going to collaborate with this professor and see collaboration letter. And this is what, and in my proposal, I will describe that what he will be doing in my career project. And then for the rest of the collaboration letters, I have 3 that's for my outreach collaborators. So I already established partnership with them, like since I joined San Francisco State University, because I do these outreach activities every year, so I know them well, they know me well. So also they basically are like outreach coordinators for just one of the educational objectives of my education plan. And then the other collaboration letter was from education evaluator that I just contacted. She was assistant professor from education department in our university. I contacted her a few months before I submitted my proposal. Just asked her, "This is what I plan to do. Are you interested in being part of my project?" And then the last one was from a director of it's called some computing center for our college. That's basically, he provided the letter to provide support and facilities for one part of my research plan. Because like I said, for each research objective, I have preliminary results or prior work. If I don't have sufficient like a published work, then I would say, I plan to do this. I may not have this preliminary results, but I have the support from my institution, and you can see the collaboration letter from this director who will provide support and expertise for my research. That's the building a cloud computing platform for one of my research objective. So these are the 6 collaboration letters I collected. Yeah.
So to add on that, I did a similar thing. I had 4 collaboration letters, and for things that I had not done before, like I think for part of my proposal, I said I was going to use transduced cells, and I've never made a virus. I've transduced cells before, but I said I was going to get it from the collaborator who, that's what she does. And then I just said, see collaboration letter. So it wasn't a huge portion. It was like, for this, I'm going to do this, see collaboration letter. I had 2 for research and 1 for education and 1 for outreach. And each part, like exactly like what she said, I will be working with this person, parentheses, see collaboration letter.
One last comment on that. I think you can use the collaborations as a way to ease any potential concerns that the reviewers might have. So if you anticipate that they'll say, for example, in my case, when I say, oh, we have all these different images, we're going to analyze them, and I have some expertise on these, but if things get more complicated, then there's a collaborator that we work with, and name, description of why this person is the best person to help you on that, and then you move on.
And you can include the facilities of your collaborator in your facilities document. So if they're providing you with facility expertise or access, that should be part of your facilities description. Additional questions? Yep.
One more question about the collaboration letters. The quality of the collaboration letter writers, not the quality, the popularity, I will say. So is it better to find, maybe reviewers will be better to answer that, let's say I want to work with a simulation person, and I know a friend who started with me as an assistant professor, and we are super excited to do it together. However, he started with me. On the other hand, I can find somebody who is like 25 years old doing this job, super popular, National Academy of Science, but I want to do it with my friend. Which one I should choose?
Do with your friend.
Really?
I mean, I think that as long as your friend knows what he's doing, then it's totally okay. As long as he can show expertise, then that's okay. You know, we're not looking into this. You know, at least I'm not, you know, we are told this. NSF tell us, like, don't look at, you know, where the student graduated from, how long, and, you know, what is the pedigree, who do they work with. We're trying to be very objective. So if there is a big shot, I mean, I personally don't look into that, right? I say, okay, this guy knows what he's doing. He has published. He's young, fine. I mean, it's not, we really are not, at least I'm not biased by, you know, the big shot. On the contrary, you know, like I try to help young people. So, yeah, that shouldn't be a problem.
So I want to echo what Rafaela just said, that I also am someone as a panelist that really pushes hard to not be biased by these things. What I do, but I'm not going to tell you which one to go with. What I do want you to consider are people's unconscious biases. And that's something that at the beginning of the panel, our program officer will raise to us. And I think that when we think of these kinds of unconscious bias of whether, let's say you'd weigh heavily a 25-year veteran with National Academies of Science versus someone who might not have published as much, when you weigh what those unconscious biases are, I think it really does take a lot of training to get past what we've been told is something we should be, you know, biased towards and say, no, we should value this. So in answering your question, I want you to really think about how much you want to really hope that we are fully trained in that and ready to truly accept what we should be accepting.
So let me just add something real quick. If you're an expert in something, right, and you are probably one of the best people to do that, and if your colleague, junior faculty, is also the expert on this other thing, then that person, to some extent, will be well-known or known for that and has those credentials. So if that is the case, then I wouldn't hesitate to put the younger collaborator. I would also, I would be curious to hear from people who actually review this, but I would be concerned that if I put in somebody who's really, really senior and I rely on them a lot, that will not look like you're independent. So I would really watch for that.
Yeah, I would say that. And the other thing is, for an unsolicited proposal, you can actually go in with collaborators. So a career, you have to be a single PI. Unsolicited, you can have as many collaborators as you want. Part of that collaborative effort is describing and convincing the reviewers that the collaboration will work. And so in that case, having somebody close by or that you've worked with before is actually a plus, rather than going out for the big name person who maybe will shoot you an email once a month sort of thing. So, so think about that, especially for unsolicited proposals. Are there any other?
I would add to that. I would say, and if you're really like can't decide, hedge your bets. Say, my friend is going to be my collaborator. This big shot's going to be a consultant.
Can I add something? I feel like when it's already at the point of writing this proposal, this collaborator, no matter what his or her background, I mean, it would be best that he or she already has the partnership with you. It's not that you just, now because of this proposal, you need to just find someone for this proposal. That you have to show that we have already just healthy collaboration, we have already some solid previous results. So that's why I included him or her into my proposal. Yeah, and a career proposal again is just single PI, so it still is just mainly focused on your independent work. This collaborator is just some small part maybe support it. Yeah, that's my personal experience.
Yeah. If you can come to a mic, please. And while he's coming, those of you who happen to be in the room, I've been waiting for a solicitation to be published and through the system for ages, and it's driving me crazy. So anybody who does tissue engineering or mechanobiology, please look up solicitation 19-509, which will be coming out within 24 hours, which focuses on tissue engineering and mechanobiology on the International Space Station. So stop by our booth, pick up the postcard, which now we can reference a solicitation number for, but you get early advanced knowledge of the fact that we will have this new solicitation. And question?
Yes. Hello, everyone. I'm Keija Mwako. I'm an assistant professor at the University of New Haven. My question to the panel is that how much does it hurt the applicant if the project that they're, the proposal or the problem that they're trying to address has been already, there are several, or maybe a couple awards made to addressing such a problem. Let's say curing cancer. In the last 5 years, 5 careers have been awarded for, exploring different approaches to that goal. Does that hurt?
Well, we have not cured cancer, right? So I think clearly we need different approaches. I think as long as the approach and the science and the engineering that you are developing is different, there is no problem. The motivation could be the same. So I don't think there is any constraint or we need to fund, different projects on, with different motivation or translational aspect. I think that what you need to show us is that the advancement of science and engineering that you're proposing is different from what the other 5 people have proposed.
If you have any doubt, talk to your program director. I mean, you can just tell by the tone of their voice whether they're excited about that or not. I mean, for my case, I remember talking to the program director, and I said, I have this really nice idea to try to detect glucose levels without having to puncture your skin. He's like, I don't care about that. I was like, okay, got it. So just talk to them.
Yeah. No, and that's the key thing. Some program directors really focus on the balance of their portfolio, and they've shifted in a direction. Others, like me, want to fund the best science and engineering, and I don't care what the area is as long as it fits the scope of my program. So again, have that conversation, get that information, and that'll help guide you.
Okay. And the other one is, how do you tag your proposal as an RUI? How do you tag that?
So there's information in the PAPPG about doing that, and there's a special code that you submit through, and then RUI goes at the front of the title.
Okay. Thanks.
Next.
I'm Corey Bishop, assistant professor at Texas A&M University. I have a question for Xiaorong Zhang. Sorry if I mispronounced that. My question is, so at the end of your presentation, you said that I'm doing this work whether or not, you gave this message in your proposal that you're doing the work whether or not it gets funded. I've heard another say that they should basically be saying, I can't do this work without the funding. And so I was just wondering, maybe we could have a discussion, and it doesn't need to be just Xiaorong Zhang speaking, but I just thought that'd be great to talk about that more.
I think more accurately, I wanted to convey that I'm really passionate about this work, and I have done a lot of preparation for the work I proposed, and I have the qualification of doing them. And this is something I'm passionate about, and I want to do it anyway. But of course, I need support to do that. So, that's what And
I think the idea is that all of us need the money, and they're not going to give it to you just because you need the money, and they're not going to not give it to you because you say, I'm going to do it no matter what. So I think the way she stated it was just like, this is my passion, this is getting done. And it didn't hurt in the sense that it's, oh, she's already funded, we don't need to give her money. Or, oh, well, this person, it's not a needs-based award system at all. Otherwise, I would have gotten it earlier.
Any other questions? Okay, well, let me introduce the other program directors that are in the room so that you have people that you can target during this networking portion. So over here, Rich Dickinson, behind the pillar for half of you, is our division director in CBET, and his expertise is in cellular engineering. Alex Simonian is back here, took over for me for engineering of biomedical systems and disability and rehabilitation engineering. He also just was recently the program director for biomaterials, so you can always pick his brain on that one. Cheng-Jong Lee is somewhere? No, he left. Is biosensors. He will be back at the table tomorrow morning. And Stephen Zender is the associate program director for engineering of biology and health, which is a cluster of programs in CBET that cover all the BME, or the main BME-related programs in CBET. So he's a great person to talk to about things in general, with the caveat that he started a month ago.
I did start a month ago, so I hope if you haven't talked to me at the table, I'm not too long. Trying to figure it out.
So, and then I cover biomechanics and mechanobiology. I'm sure some of our panelists would be willing to answer additional questions, so feel free to stop them. Thank you very much for attending. Next year, I'm sure this is going to happen again. I don't know who will be up at the podium because I will be back in your shoes as a faculty member, but encourage your colleagues to attend because I do think the more times you hear things, you always pick up new bits and pieces. Anyway, thank you very much.